Welcome to Modernizing Scenario Analysis with SAS Viya and Visual Analytics. My name is Stu Stokowski, and I am a co-author on this paper, as well as an analytic consultant here at SAS, where I help customers create end-to-end forecasting solutions. Scenario analysis is an important part of decision-making, and it can be a challenge to create an interface for users to run scenarios on your model. The SAS Viya Job Execution Service allows you to create interfaces to run your model, whether it's in SAS, R, Python, or an API, all with relatively little coding. Today's presentation will be split into two parts. First, we'll talk about what the Job Execution Service actually is, and go through the basics of how to run a scenario in it. Then, we'll go and talk about how we can actually run a scenario through Visual Analytics using a dataset called sashelp.snacks. Finally, Arne Cordes, my co-author, will go through a real-world example of how he took all of his modeling, all of his dashboarding, all of his scenarios, and all of his black box model explanation and centralized it into one location for executives to review. Let's get started. Whenever you're implementing scenario analysis in SAS Viya, your code needs to do these three things. Needs to modify your data, needs to score it, and then load it into CAS. No matter what you're using, whether it's SAS, R, or Python, if it does these three things, you can run a scenario. If you want other people to run your scenarios, you need to get it out there to them. And an easy way to do that is through the Viya Job Execution Service. The Job Execution Service is SAS code that runs other code. It doesn't matter what that code is. It could be other SAS code, could be R code, could be Python code, it could be an API that you call. As long as it does these three things, other people can run your scenarios. In a nutshell, you can think of the Job Execution Service as a URL that people access and SAS code runs. They can modify that URL to make the code do other stuff. And they can do that using job input parameters. Job input parameters are user-defined values that automatically translate into macro variables when the job runs. You might see where this is going already. For example, let's say we've got a job with a parameter named date defined in it. A user goes to the job execution URL, runs a program called myJob, and then they change the date parameter within it. When the job runs, we can access date as a macro variable, and it will come out as 01Jan 2020. This is how you'll modify your data. Well, that's great and all, but is there a user-friendly way that people can do this instead of having to type stuff in a URL? The answer is yes. Jobs allow you to add forms and HTML interfaces to them, and these can be linked and displayed in a Visual Analytics Web Content object. And this is what brings it all together. Now, we're going to focus primarily on an HTML interface today, and let me tell you, I have very little HTML experience. In fact, almost all of my HTML is brought to you by Stack Overflow. I don't know where I would be without Stack Overflow, but I wish I could cite every single person whose HTML code that I used. So if I could do this, you could do this. Let's get into the demo and show how we can make some really simple scenarios using pretzels. Here we are in SAS Studio 5, which will be our main way in which we can edit and work with jobs. Before we begin, go to Options, Change Perspective, Standard. If you're not in Standard mode, you will not be able to edit and work with jobs. If you want to make your own job, click on New, Job, Definition. And from here, you can add your SAS scoring code or your Python scoring code. Whatever you need to include all goes right here. If you want to associate a form with it, on the right side, you'll click that, add an HTML form. And if you want to add or edit job parameters, you click on the Parameters button. We've already got a job ready to go that has all of this stuff configured for us. So for this example, let's pretend like we're a large grocery store chain and we need to forecast the number of jumbo pretzels being sold at one of our stores over the next couple of weeks. I quite like jumbo pretzels, and in this example, management would like to know what would happen if they increased the price of pretzels and what will happen to profit if the cost goes up. So let's give them the ability to do that. So let's go to our model scoring job that's already been made and just look at the top section here. If you look at the top section, this just calls my scoring code. It lives right here. This does my modification of the data, it scores it, and then it loads it into CAS. Nothing more. If we look on the right side, we could see where all of our parameters are. Now, here's a cool one. Action. This is an automatic parameter that is a part of every job, and we could give it a default value. And here, what we're telling it is, display an HTML form first, then execute the code after the user clicks submit in the form, and display a nice waiting page for them. I really like that. If you include that, you don't need to worry about coding one. Output type. This says display an HTML web page when we write to a special file name statement called webout. In this case, we just want to display a web page for them. And this is an output web page that quite simply says your pretzel modification was successful and a go back button. So all you're doing is writing to webout, and webout knows that this is going to be HTML. On the bottom here, we've got our price and cost. So let's click on run here really quick, because you've already got a form associated with it. When the users edit and work with the form, here's our price and here's our cost. So let's look at our HTML form. This stuff at the top, nothing more than making it look pretty. On the bottom here, in the body, this is our form. We need to have 3 form inputs and 1 specific action. Make sure your action is for SAS job execution. This program statement says to run the program that we're in. This action says to skip the form, just execute it, and then give us that waiting page. And then CSRF, this parameter, it just says produce a cross-site request forgery token. It's required. If you don't put this in here, you might get some warnings or errors saying that you don't have access to do this. And then finally, we've got our 2 input statements. The only thing that matters most here is this name is equal to your parameter. They will be automatically posted whenever they click submit and made a part of that URL. So your URL gets generated with all of those ampersands that are in here. Now let's look and see how we can take this form and put it into VA so that other users can use it. This is our Visual Analytics dashboard for users to see what happens to our jumbo pretzel demand at our grocery store over 2 weeks. Here we've set the report to automatically reload data every 5 seconds so that when users run scenarios, it gets picked up right away in the report. Now here's where our job actually lives, on this small little hidden page here called Start a New Scenario. It's just a web content object. And that web content object points to our job. And our job is always located in the same place no matter what server you're running. It's always the same type of URL. It's your viaserver.com/sasjobexecution/?program equals, and then wherever your program is. Since we've already set defaults to show the form, Via is automatically just going to display the form for you without editing any other parameters within this URL. So let's run a scenario. Let's click Start a New Scenario. And we're going to make this $1.30 because we get these things for pennies on the dollar. And we won't change the cost. We'll click on Submit. Now there's that wait action in action. And there's our small little data step web page that we had made. So let's close this. And let's select our new scenario. We could see that our profit increases by 81.1%. So that's pretty nice. Apparently people rush out to buy jumbo pretzels when they're dirt cheap. Well, let's compare a bunch of scenarios that we've run. And we could look and sort this in descending order and see exactly which scenarios tend to work best. So here we could see that if we set the price to $1.50, we actually make more money than if we set it to $1.30. And this is how users can very easily compare and look at multiple scenarios all at the same time.
My name is Arne Cordes. I work for Volkswagen Financial Services in Barcelona, Spain. I'm responsible for advanced analytics. We started our journey into this fascinating field in 2016 when we ran Enterprise Guide. In 2019, we upgraded to Sasvaya. Since then, the deployment and the 360 degrees analytical cycle have become a dream coming true. We've grown our portfolio of use cases. And in this video, I will talk about the use case in the context of residual values for the remarketing of cars. I hope you enjoy. When modeling in visual analytics, I find it really useful to make use of the missing value trick. What it basically does is to derive a score from your model for those observations of the target variable that have a missing value. This is really useful because it prevents you from writing a dedicated scoring statement like a proc PLM, because you can use it on the flip in Visual Analytics. Here I have created some 12,000 missing values for the target variable. In this case, it is the brand. And I want to explain it by the model. Okay, so when I derive a predicted from this algorithm, I can see where I had the missing values for the target variable, I get a score. So let's put into practice the missing value trick. Here, the decision makers, they want to know and they want to run a regression model on a specific grid of points. For example, they're interested in the behavior at 12 months, 24 months, and 20,000 mileages per year, for example. So here we prepare the data set with the missing values. So we have the real observations that are used for training the model later on, and we have added fake observations at specific grid points the user can define. For example, here we want to define and limit the range of the observations, the real observations. And here we can choose the brand. We want the grid to run until 60 months, and we want to have it at the 3 months step. So it gets updated with the data-driven content and the job execution behind. And we can see here that we have the different step functions with a missing value applied to it. So here we see that the data-driven content allows for customized variables to be passed to the final data set. All these variables that are passed through the final data set are later on available for the modeling. Now we are ready to model. We see the 1000 missing values that get derived the score once we derive it predicted. So the next challenge we had to face was the following. The prediction is the best guess from an analytical perspective. But for running the business, it's important to overlay a commercial decisioning on this. This means that if we define a model at 70% at 12 months, perhaps it makes sense to lift up until 72% so that it gets a better monthly rate and can defend better against competitors. So let's allow for this. Here we give the user some prompt. He can choose the different models and he can choose what he would like to do with a specific value. In this case, for these two models at 48 months, and he wants to lower the residual value, the final residual value by 2.6%. So we allow for data-driven content and the job execution in the background, and all these different modifications and commercial adjustments get recorded. So here we can see the latest adjustment we've made at this specific time with the final value. Let's add another feature to this report. We finally decided upon a commercial adjustment for residual value estimate, which is expressed as a percentage of the list price. So we can create a calculated item to express it as an expected value for remarketing this specific car. We are talking about a car which is 4 years old, and we've created a price range which we will use as a filter. Now with a cross tab, we can use a URL link and we can pass different parameters to a specific web page. So now we click here, it takes us to this page. It passes the different parameters, and here we see they are applied as filters. And taking a look at the different prices, we can see that our estimate is quite okay. So we have made a reality check for it. Often there's a downside for the champion model. If it's a sophisticated algorithm that you are running, the interpretability suffers a little bit, and it's not easy to share these insights with the audience, which is not so literate in data science. So a good starting point is to share the variable importance, which for gradient boosting is one of the standard outputs for the model. But in my opinion, it's not enough. You have to create somehow like interpretability charts, which are available in built models. But I wanted to have more control over them. So I used EML language for this. So I create the most relevant permutations of the character variables, and I create a grid. Once I have the grid, I score the grid with the gradient boosting scoring code, and I bring it to Visual Analytics. And here we can say, for example, we want to check for the optional equipment and what effect it has on the gradient boosting scoring. No? So here we see that with more than 6,000 euros in optional equipment, the residual values suffers, it drops a lot. And if you read this information together with the frequency plot of what your portfolio looks like, you can grasp the exposure, the risk exposure you have with your portfolio, no?
We've gone through some real-world examples of how to modernize scenario analysis in SAS Viya and Visual Analytics, and we've gone through a basic application of scenario analysis using Viya Jobs. Now, this information gives you the building blocks to start creating your own scenario code and dashboards, and all of our code and data will be available for you to use on GitHub. But what if multiple people are running scenarios at the same time? What are some tips for building a scenario analysis dashboard? And how could you use data-driven content to create near real-time data or scenarios? All of this and more is answered in our paper, which you'll find at communities.sas.com. See you there.